Hello everyone. We are finally at the point that we can start using bar chart to see a couple of cool relationships that exist in the Wickham dataset. We're going to be using the unstacked, stack, and multi-level index and columns heavily to be able to create different types or different ways of doing the bar chart that may actually have influence in the way that the bar charts is communicating the information or communicating the data and process that as an information that is shown to the audience. So let's get to it. As usual, importing the modules that we need, and then we read the data and also the group by that we did, so it would enable us to create a table that sort of like shows all of the relationship between the outcome and also the smoker. That we can see how many people are at how many data rows are at what state based on these two columns. So right off the bat, one of the things that we do to make these numbers more presentable, we normalize them. By normalizing them, we make them into a state of numbers that we can simply look at them, and they give us a very simple way that for us to be able to compare them. So try to get to a percentage instead of the number of people or number of data rows in this data. Try to get to the percentage of data objects for each of the possible combinations. So basically, I want to see a percentage of percentage here instead of the total number. Give this a try and continue watching next. So it's fairly simple. All you need to do is really divide that by your unstacked data, divide that by the total number of data objects, because the summation of all of these data objects is just the total, is the number of the data rows in your table, in your data set. So once you divide all of these values by that, then you will get to a point that you have your unstacked data frame that you can see now the values based on the percentages. If you pay attention here, there is an astounding fact or astounding pattern that's coming from this data. And that astounding pattern is the fact that if you're a smoker, you are more likely, 3 times more likely to be alive than if you're not a smoker. So whatever you're doing, stop and go buy a pack of cigarettes and start smoking, because it's going to, basically give you more chance to live. I'm only joking. So this is actually a part of this lesson for you to understand that a lot of times there might be some patterns from the data that comes through, but there are other things about the data that that manipulation of the data is not considering. And here it's just one of those examples. So no, please don't go buy a pack of cigarettes and smoke does kill. Smoking does kill. That's not a good habit to have or even to start. But as the part of the assignment in this video, you're going to have a chance to use bar charts to explain what's happening here. But let's continue and see, those building blocks that you need to create those bar charts before I challenge you with the assignment. So the challenge I have here, we want to draw a bar chart that instead of looking at these numbers that are great, this is much better than what it was before. Now I have percentage, and percentage is a comparable number. I know about the percentage. It's from either 0 to 1 or from 1 to 100. And like as a person who has been working with numbers, like working with percentages is straightforward, and I can compare them easily in my mind, and that's something that is better than having those numbers. So maybe I can see this is bigger than this one, but to what extent I need to do some calculations, but I'm more attuned to the percentages. And when I say I'm just saying that as a person, as a human, or as a engineer. I'm more attuned to comparing percentages. But the whole things about visualization is now we want to take that to the next level. So I mean, like from those count to the percentage, there is an added value as far as being able to compare those values now. But once you move to visualization, now you don't have to work with numbers. You are showing the differences with the bar chart, and it's more visual, and now it's much more easier as a human to be able to look at them and actually see the differences. So that's basically why we are doing the bar charts here. So this is not a challenge for you to do it on your own. This is basically me telling you what we're going to be doing for a little bit of what's going to come ahead. So there are 6 ways that you could actually be doing the bar chart. The first one is basically doing 2 simple bar charts based on different columns. So I am using the smoking DF, and based on the columns I do the value counts and do the bar charts. When I say plot, I say bar, and then I specify the color and also the limit. And once I run this, I am putting the charts next to one another. So pay attention, the reason that I have this while is because I want this to be comparable. I mean, you see here I have till 700, but this is till perhaps 100. That's why I have specified that limit. And also, the reason I'm specifying the color is because if I don't, it's going to give a separate color to all of the instances here. So let's run that by that and see we have like unnecessarily colors that they might not add anything to our visual, but it might just like be creating unnecessary cognitive load. So let me revert it back to how it was. And now this is one way we could be doing this. Another way we could be doing this is as we saw when we do the group by, we can also do the plot based on the group by. So now pay attention here. I have a multi-index data frame. So here I had like my original data frame, so I had to do the value counts and then on top of that do the plot. But here I can do the plot on the multi-index, and once I do this, multi-level index, and once I do this, now I create the same plot basically as far as the values, but now I have to keep track of the multi-indexes based on these no alive, no dead, yes alive, yes dead, which is basically the same data here, but this is a little bit neater basically than this one. So that's one way, another way of doing it. Another way of doing that is by doing the plot on the unstacked one. So if I do the unstacked, so that this is my new data frame, and now based on that unstacked, I say plot then the kind of the plot I want it to be bar. Now it gives me the type of plot that's starting to look very professional, but at the same time, basically it's the same data that is here, but now it's close. These are attached to one another, and I'm using color to distinguish between alive and dead. And the reason I'm doing the ylem here, just doing that to make it a little bit more presentable. But we don't actually need to do that. So this actually looks better if we don't do it. So another way of doing a plot is, instead of having these two next to one another, is to stack them. So imagine, pay attention here. We unstacked the grouped by data from multi-index to multi-column, and then we plotted that. Now we want to do the stacking in the bar chart. So the way you do that, you say stack true, and then what's going to happen is going to stack these orange boxes on top of the blue ones, and that could be a very valuable visualization for a specific case that you want that to be stacked on top of. So that's another way of doing this. Also, as far as the bar charts go, you can see I am having smoker, yes or no, on the x-axis here, and on the y-axis is the number of rows in the data, and also in the legend or in the data input I have another attribute, which is alive or dead. What if I want to switch that? I want to have alive or dead or outcome here, and as different types of data entry I want to have smoker or not. That is completely possible, and all you need to do is, instead of doing group by smoker outcome, you need to switch that. You need to do group by outcome smoker, and do whatever we did. Do that group by, and then calculate the size, unstack it, and once you run this, now we have what we were looking for. Now outcome is here, and the smoker is being shown as the legend. Now I could also be wanting this to be shown as the stacked bar chart. All I need to add is saying stacked is equal to true. So now I have the stacked bar chart. So I have an analytic challenge for you here. It's not a programming challenge. I want you to look at these 6 figures and tell me which one of these figures is really doing a good job of showing the influence of smoking on the outcome, which is being alive or dead. Which one is sort of like giving the best story as far as one person wanting to see the influence of smoking on the outcome, which is outcome of your life, if you're alive or dead. Think about this a little bit and come back, continue watching. I will be doing some discussions for it. So there are a couple of the visuals here that are just not a good option as far as how presentable they are. The number 1 and 2, they're not really presentable visuals when you compare them to the other options that we have, these 4 options that we have. And between these 4 options, I would say the option 3 is the best one, because now I can see that if you're smoking or not smoking, how much change it has on the probability of you being alive or dead. So here, if you're not smoking, the ratio of being alive is higher, there's more likely for you to be alive than if you're smoking. But if you pay attention here, the number of people who are dead and not smoking is more than the number of people who are dead and smoking, which was the confounding observation we had. And there is a confounding factor, we have to figure it out. But basically, before we get there, this is the best visual out of all of them. But why not this one? I mean, these are basically showing the same thing, but just the the visual, or where the boxes are at different places. So this one would have been great if we really cared about and wanted to know about the total number of people who are not smoking and smoking. So we can see that difference here clearly, but it doesn't allow us to do comparison between how much smaller this is comparing to this. How much smaller is this than the blue one, comparing how much smaller is that to the blue one. So because of that, this is better because this gives us that comparison, and the total numbers of alive or dead is not the focal point of comparison or the story that is being said here. And the other two is sort of not being intuitive as far as the influence of smoking on being alive or dead. This is sort of like the opposite of it, and that's why the number 3, the chart number 3, is the best one to answer that question. So let's continue here. We also want to be able to see the relationship between age and these two categorical attributes. So that's where basically age is that confounding factor that I've been talking about. So that's where it's going to be shown for us why, if you are, I mean, at least in this data set, if you're smoking, there is more chance for you to be alive. So for us to be able to do that, we have to see the relationship between age and these two other categorical attributes. But we saw that age is a numerical attribute, but these two other attributes are categorical. So a common practice to be able to do this calculation or find this relationship or portray this relationship is to categorize the numerical attributes. And once you do that, now you have another categorical attribute. So now you can use bar chart to see those relationships. So the way it's normally done, the categorization, you could do it in many different ways, but one of the easiest one is to use the Pandas cut function. And the Pandas cut function basically allow you to transform a numerical attribute by the cut points that you want to be implemented. So I'm putting what cut point at 17. If you remember, the minimum value in the data was 18. So I'm putting what cut point at before the minimum, and then all the way to 32, between 32 to 46, and then 61, and the maximum, if you remember, was 84. So I'm basically in effect creating 4 different age groups here. You could be playing with this, you could be creating 5 age groups, 6 age groups, and there could be some analysis that goes to finding these groups. I'm not going to go over those things. That could be another topic of conversation. But let's just say these are the age groups that we want to create. These are the 4 age groups that we want to create. And by doing this code, now I have added another column to my data. It's age group. So now, because this is also categorical, now I can also do group by based on the age group, or do the value count. So I have these value counts based on different age groups. So now I want you to be challenged by this challenge here. So Draw a bar chart that shows the relationship between age and smoking. Give this a try and continue watching. So it's very simple. All you need to do is to do the group by based on age group, and then smoke it, and then say the size, and then unstack it, which basically is going to unstack the smoker one. So it's going to go to the column, and then do the bar chart. So once I run this, now I have all these age group and then the smoker here, and I can see that the older you are, the less likely, not actually here. So the older you are, the oldest group is less likely to be smoking than the younger group. You can see it here. And yeah, another challenge, now do the same thing, but now I want to see the relationship between age and outcome. Give this a try and come back as I will be showing how it's done. So all you need to do is really change this smoker to outcome, and that's just going to do the trick for us. And now I can see that, of course, this is a no-brainer that the younger you are, the more likely you are to be alive.